And up until now, we've been going through basically different axioms and theorems. We've been going through different shapes as well. In particular, polygons is the word that we use, which is a many-sided shape. And we started off with three-sided shapes, which we obviously know as triangles, and we went through some theorems and axioms to do with triangles. We then looked at different other types of polygons and some of the properties to do with polygons. And now we're looking at special types of four-sided shapes, right? So four-sided shape being a quadrilateral, and we looked at quadrilaterals and we saw that the angle sum is 360 degrees, and it's a four-sided shape, etc. But what I do want to do now is look at some special types of quadrilaterals, and this is something that you should be fairly well familiar with. So let's have a look at some special types of quadrilaterals, and there's 6 in particular that I want to focus on. They are the square, the rectangle, the rhombus, the parallelogram, the trapezium, and the kite. Okay, now just by looking at some of these shapes, you might be well aware of what these shapes look like. I want to actually delve a little deeper and delve a little bit more mathematically into what makes a square, what makes a rectangle, a rhombus, etc., etc. And we're going to look at special properties or some properties to do with these special quadrilaterals. I've got 13 of these properties up on the board, okay? And I'm going to go through each of these 13 properties for each of these shapes. And we're going to go through and make a bit of a checklist, a bit of a table for each of these special quadrilaterals. And you will find that the properties that are unique, so the properties that apply to each special quadrilateral is unique to each of those special quadrilaterals, which means that they're the properties that define or make up that special quadrilateral. And you'll see what I mean when we go through it. So let's start with the square. All right, now the square is probably the most special quadrilateral of them all. What makes it so special is that it will tick just about all of these boxes. Okay, so let's go through it. Okay, so the first one with a square is, okay, let's start with the first property, all right? One pair of opposite sides parallel. Does a square have one pair of opposite sides parallel? It actually has two pairs of opposite sides parallel. So these two pairs, so this pair, this one, and then this pair, this one and this one, they're parallel. Okay, so they've got two pairs of opposite sides that are parallel, which means at least one of them is parallel. Okay, I'm actually going to put a tick there, right? But this one actually applies specifically, right, to another quadrilateral. It's going to apply specifically to a trapezium, and I'll put a special note in that one. Okay, I might even give it like a star or something. All right, opposite sides parallel. Now, does a square have opposite sides parallel? Yes, this side is parallel to this side, and this side is parallel to this side. Yeah, so I'm going to label that like so. All right, so that's the sign to say that they're parallel, and that one's parallel as well to that one. Okay, so yeah, this one's true. Opposite sides are equal. Yes, the opposite sides are equal. In fact, we're going to go one step further. Not only are the opposite sides equal, all the sides are equal, yeah, in a square. So let's tick that one and that one, okay? So that's equal to that, which is equal to that, which is equal to that. Got it? All right. Two pairs of adjacent sides are equal. Yep. And the answer is yes, two pairs of adjacent sides are equal. Adjacent sides meaning sides that are next to each other. In other words, this side is adjacent to this side, and they're both equal to each other, right? And you can say the same thing for these two sides as well, right? And the reason why that'll be true is because all the sides are equal. Diagonals are equal. And yeah, in a square, yeah, the diagonals are equal, all right? So if you were to put the diagonals in, right, in other words, from here to there, all right, let me just use a ruler to show you what I mean. You will find that the diagonals are equal, right? That diagonal there is equal to that diagonal there. Not only that, the diagonals will also bisect each other. In other words, this diagonal gets cut into half by this diagonal, and vice versa. This diagonal gets cut into half by that diagonal. Got it? So that's really what diagonals bisect each other mean. Diagonals meet each other at right angles. Yeah, they do. In fact, what you'll find is that that's a right angle there, which means that's a right angle there, which means all of the other angles are right angles. Okay? Good. So the diagonals meet at right angles, tick. The diagonals bisect the angles through which they pass. In other words, this angle is equal to this angle and vice versa, right? So the angle through which the diagonal passes will be bisected by the diagonal, okay? Which means that angle is also equal to that angle and that angle is equal to that angle too, right? Cool. So yeah, the diagonals bisect the angles through which they pass. Definitely spot on. Opposite angles are equal. Well, all the opposite angles are right angles, so yes, they are equal. One pair of opposite angles is equal, yes. All right, but that's going to apply specifically more to one of these quadrilaterals over and above the others. All angles are right angles, yes, and axis of symmetry. Now, how many axes of symmetry does a square have? Well, we can see at least two, right? 1, 2, but there's going to be two more. There's going to be this one here, which cuts the square into two rectangles, and then there's this one here, this horizontal line and the vertical line. So that altogether makes 4 axes of symmetry. Got it? Okay, cool. Let's have a look now at rectangles. All right. So for rectangles, one pair of opposite sides parallel. Yes. Opposite sides are parallel. Yes. That side's parallel to that side. And that side is parallel to that side. Yes. So opposite sides are going to be parallel. Opposite sides are going to be equal. And that's true too. So this is going to be equal to this. This is going to be equal to this. Opposite sides are going to be parallel, are equal too. Opposite sides are equal. All sides are equal? No, not all sides are equal. All right, so that's a cross because that's a square that we're referring to being all sides are equal. A rectangle won't have that property. 2 pairs of adjacent sides are equal. Well, let's have a look. Is that side equal to that side? No. Is that side equal to that side? No. Is that side equal to that side? No. And is that side equal to that side? No. So 2 pairs of adjacent sides are equal. The answer is no, right? The diagonals are equal. Yes, in a rectangle, the diagonals will be equal. Do the diagonals bisect each other? In a rectangle, yes, they do bisect each other. And you can use similar triangles to congruent triangles to work that out. The diagonals meet at right angles. The answer is no, they don't. They don't meet at right angles. Do the diagonals bisect the angles through which they pass? The answer is no, they don't bisect the angles through which they pass. Opposite angles are equal. Yes, all of the angles are right angles, which is this one over here. One pair of opposite angles is equal. The answer is yes, because all of the angles are right angles. How many axes of symmetry does a rectangle have? Well, a rectangle will have 2 axes of symmetry, right? It'll have this axis of symmetry here, this axis of symmetry there, this line here, right? Because the angles aren't the same, all right? Because the diagonals don't bisect the angles through which they pass, what you'll find is that the diagonals do not make an axis of symmetry in the same way that the diagonals of a square does. All right. So let me just draw the diagonals to just let you see what's going on, and then we'll take it from there. Yeah. So there we have it. This angle is not equal to this angle. All right. So I'm going to just make them different. Okay. But what you will find is that this diagonal gets cut into half by this diagonal, and this diagonal gets cut into half by that diagonal. Yeah, so they do bisect. These 2 angles, they do not bisect they do not bisect the angles through which they pass, and they do not bisect each other at right angles either. All right, so that's important to note with rectangles. All right, let's now have a look at a rhombus. So for a rhombus, you have one pair of opposite sides parallel. You do. In fact, you have two pairs of opposite sides parallel. So you got this side being parallel to this side, and you've got this side being parallel to that side. Now, a rhombus is simply just a square that's been slanted or tilted across, right? Do you see that this is just a square that's just been kind of lopsided or made to look lopsided? The opposite sides are parallel. Yep, that is certainly true. Opposite sides are equal. That is certainly true because all sides are equal in a rhombus, right? And what makes it a rhombus is the fact that all sides are equal, although all angles won't be right angles, all right? And all angles won't be equal either, all right? Two pairs of adjacent sides are equal. Yes, all sides are equal, so that's going to be true as well, okay? Diagonals are equal. The diagonals won't be equal because the rhombus is lopsided. One of the diagonals will be one of the two corners. One pair of corners is going to be closer to each other than the other pair of corners. All right. Diagonals bisect each other. The answer is, do the diagonals bisect each other? And the answer is yes, the diagonals do bisect each other. Let me just draw the diagonals so that you can see what's going on. So you've got one diagonal there, and you've got another diagonal here. Yeah, I do want you to see that yes, the diagonals cut each other in half, right? So the diagonals bisect each other. Do they meet at right angles? In fact, what you'll notice is that they do, right? So the diagonals meet each other at right angles, and you can pretty much work that out using congruent triangles, right? Which we looked at earlier. Do the diagonals bisect the angles through which they pass? The answer is yes. You'll find that this angle equals to this angle, this angle equals to this angle, this angle equals to this angle, and this angle equals to this angle, although this angle does not necessarily equal to that angle. Okay, cool. So yeah, the diagonals bisect the angles through which they pass. That's certainly true. Opposite angles, are they equal? Yeah, you will find that this angle is equal to this angle and this angle is equal to that angle. That's going to be true. All right. In terms of one pair of opposite angles equal, yeah, one pair of opposite angles is going to be equal. In fact, both are going to be equal. But that one, like I said, refers specifically to kites, where you've got one angle here which is equal to this angle here, but not necessarily the fact that this one equals to that one. So for this one here, one pair of opposite angles are equal. That will specifically apply to kites. So where we move along, one pair of opposite angles are equal. That's going to specifically apply to kites. So I'm going to put a little star there, right? And then how many axes of symmetry does a rhombus have? And what you'll notice is that this angle here, oh sorry, not this angle, this diagonal here is going to be an axis of symmetry, and this diagonal here is going to be an axis of symmetry. And the reason why you can see that is because these two angles are equal, these two angles are equal, the size of these angles are equal, all right? So that's going to fold over onto there, and vice versa that way as well. So the actual number of axes of symmetry that a rhombus has is 2. Okay, let's now have a look at parallelograms. All right, parallelograms, one pair of opposite sides parallel. The answer is yes, one pair of opposite sides are parallel. Like I said, this specific property is pretty much specific to a trapezium. So I'm going to put, and I'm going to do this ahead of time, put a little star next to trapezium for that property there, because it relates specifically to that one. But it is actually true of parallelograms as well. So one pair of opposite sides is parallel. Opposite sides are parallel. Yes, that is true. So that one's equal to that. That one's parallel to that one. And this one's parallel to this one as well. So let's put a little tick here. All right, opposite sides are equal, and that's true as well. So that side's equal to that side, and that side's equal to that side. So let's put a tick there. All sides are equal? No, they're not. Not for a parallelogram. A parallelogram is simply a rectangle that's kind of lopsided. Okay, so it's going to exhibit the same properties for that one as a rectangle will. Two pairs of adjacent sides are equal, and the answer is no. It's pretty much going to exhibit the same properties as the rectangle for that one there. Diagonals are equal. Yes, the diagonals will be equal. Okay, and let me just demonstrate that for you. So if we were to join up the diagonals of this one there, are the diagonals equal? The answer is no. The diagonals aren't equal the same way the diagonals aren't equal in a rhombus. Okay, so that one will be no. Okay, and the reason why that is the case is because, you know, these two, because it's lopsided in that direction, these two corners will be closer together than these two corners. Does that make sense? Yeah. Cool. Do the diagonals bisect each other? Does this cut this in half? The answer is yes, they do bisect each other. And the reason why they bisect each other can pretty much be shown using similar triangles, not similar triangles, congruent triangles, if we were to use that. Do the diagonals meet at right angles? The answer is no. The diagonals don't meet at right angles the same way that's not the case with rectangles. Do the diagonals bisect the angles through which they pass? The answer exactly is that they don't. They don't bisect the angles through which they pass. Are the opposite angles equal? The opposite angles are equal, right? They're equal, right? And you can work that out using parallel lines, or some of the things that you know about parallel lines, like co-interior angles on parallel lines, corresponding angles, alternate angles, etc., etc. The main one being co-interior. This one's co-interior to that one, which is co-interior to that one. Yeah. So this and this have to equal 180. This and this have to equal 180. So you take that away from both sums, and this has to equal that. Okay. Yeah. So there we go. Opposite angles are equal. Yes, we've kind of done that one. One pair of opposite angles is equal. Yeah. Well, if both pairs of opposite angles are equal, then one of them will be. But like I said, that particular property relates specifically to kites. All angles are right angles. The answer is no. And for a parallelogram, how many axes of symmetry will it have? The actual answer is that it'll have none. Okay, so 0. Okay, we lucked out there with parallelograms. Trapezia. All right, one pair of opposite sides is parallel. And that will always be the case with a trapezia. In fact, that's what defines what a trapezia is. Now, this side and this side aren't going to be equal. They could be equal, and when they are equal, that's a special type of trapezia or trapezium called an isosceles trapezium. But don't expect them to be equal. Okay, so don't expect that to be equal to that. All right, cool. Now, opposite sides parallel? No. Just one pair of opposite sides is parallel. Opposite sides are equal? No. All sides are equal? No. Okay, you can clearly see that that side's not going to be equal to that side anytime soon. Two pairs of adjacent sides are equal? The answer is no. Diagonals are equal? No, unless it's an isosceles trapezium, in which case they will be. The diagonals bisect each other? No. All right, unless, like I said before, they are isosceles trapezia. Diagonals meet at right angles? No. Diagonals bisect the angles through which they pass? No. Opposite angles are equal? No. One pair of opposite angles is equal? No. Unless, no, the answer is no. All angles are right angles? No. How many axes of symmetry are there? There is 0 unless it's an isosceles trapezium, in which case there will be 1. Okay? Let's go through the last one, right, which is the kite. And with the kite, one pair of opposite sides is parallel. The answer is no. Opposite sides are parallel? No. Opposite sides are equal? No. All sides are equal? No. Two pairs of adjacent sides are equal? This one is yes. So in other words, this side is equal to this side is equal to this side. And the answer for this one is yes, it specifically applies to kites. So I've put a little star there. Got it? Diagonals are equal. The answer is no. The diagonals bisect each other. No. Actually, what you'll find is one of the diagonals bisects the other diagonal, but not the other way around. So let me just draw the diagonals for this one, and you'll see what I mean. If we were to draw the diagonal for this kite, can you see that these two sides are going to be equal to each other? So that side's going to be equal to that side. So that diagonal there gets bisected. Clearly that is the case, and we can, like I said, prove that with congruent triangles. But this one won't be equal to that one. All right, so this diagonal won't be cut into half. So that's kind of half right. So diagonals meet at right angles. Diagonals bisect each other. That's no. Only one of the diagonals gets bisected. Diagonals meet at right angle. Yes, the diagonals do meet at right angles. So that's going to be a right angle there, which means that's a right angle there, vertically opposite angles. These ones are going to be right angles as well, simply by the fact that they're complementary, or they're supplementary angles on a straight angle. So this one, they meet at right angles. Do the diagonals meet at right angles? The answer is yes. Do the diagonals bisect the angles through which they pass? The answer for this, ironically enough, is yes. For these two angles here, they will be equal, all right, because you have congruent triangles there and there, all right. So what you've got is SSS, but not for these two angles there, right? So the answer is, technically speaking, no. Okay. Opposite angles are equal. Yes, this angle is equal to this angle, but this angle's not equal to that angle. So that's kind of half right as well, but it's not true. Okay, and all angles are right angles. The answer is no. And then the last one, how many axes of symmetry will there be? This line here is the axis of symmetry. There is one axis of symmetry. Okay, so there we have it. They are the properties of some special quadrilaterals there, right? So what I'm going to do is I'm going to make sure that this is available for you so that you can refer to that as need be. Rather than memorizing this table, tick, tick, cross, cross, what I want you to do is just experiment with some of these shapes. You might want to get a piece of paper, cut out some squares, rectangles, rhombuses, parallelograms, etc. And if you really need convincing, do what you need to do with a protractor, with a compass, you know, by folding the shapes up and seeing what happens when you do certain things to them, and basically just convince yourself and just kind of get familiar with some of the properties of these special quadrilaterals. And after a while, just by kind of familiarizing yourself with how these shapes work in that way, you will get a feel for what will be true for those particular shapes or not. Okay, but I hope you enjoyed watching this video, and I'll talk to you again soon on the next video. Thank you very much for watching.